Hello, my name's Jim Burt, and for a number of years I've been making wood turnings that incorporate 5-point stars. Now, these stars are made from 10 identical segments, and these segments are made using standard segmented wood turning techniques. And the system I've developed will quite easily make a simple star like this. I can also add embellishments to the stars. Here I have a band, but I could have multiple bands. I also have a color variation in the star, but you can also have a color variation within the border. And in addition to getting this star from the technique, the scrap that's left over can be trimmed, and we get a star like this that's complementary to the star that we were making in the first place. So there's very little wasted wood in this technique. In addition to being able to embellish the stars, we can also make stars of a particular size. I can easily calculate what I have to do to make a star of a particular size so it can fit inside of a hole that I've drilled, say with a Forstner bit. In this piece, I've drilled 13 holes and filled it with 13 stars to represent the United States. And I've embedded that in a wood turning that represents the tumultuous, crazy time that 2020 is. The system is easy enough to use that I'm willing to make 13 stars to make a wood turning. This demonstration is broken into 3 separate videos. In the first video, I'll concentrate on giving step-by-step procedures for making a simple star like this, but I'll leave out all the gory details about them. I'll leave out all the math and table saw fence adjustments and things of that nature. We just go step by step through the process to make a simple star. In the second video, I talk about how to design a star of a particular size and a border of a particular size, and then also how to embellish this star with colors and bands and things of that nature. In the third video, that's where I talk about how to make these segments with the accuracy and precision required to make a good looking star. And there I talk about the table saw sled, roughly setting the angles, refining the angles, and then finally making a template so that I can go back and set those angles easily the next time I want to make a star. And once I do all that, it's pretty easy to make one of these stars. Why don't we get started, and I'll show you the technique I've developed to make these. Everything I need to explain the technique that I've developed for making these simple stars is laid out on this table. We start with a 3-board lamination, and this board is cut up first at 54 degrees to give us these segments. Then those are cut at 36 degrees to give us the final segments needed for the star. Now, this laminated board starts off with a center board that becomes the border of the star turning blank. The outer 2 boards, which are the same width, form the star. Okay. So once these are laminated together, I run them through a thickness sander, and now I'm ready to cut these up. And I'll cut these at 54 degrees, and that gives me these triangles. Then I come back and I cut these at 36 degrees. And that gives me the segment I desire. The problem with this simple technique in that I need a board this long just to get 10 segments. I also waste this amount of wood because I don't want that walnut appearing out here. So what I've done is alter the way I cut. So these double lines represent the cut and the kerf. So I cut it 54 degrees, flip the board over, cut it again, and I continue that until I cut the board up, or until I have 10 or maybe 12 segments. But I stop the cut. I exit the board at the border between the maple and the walnut. And then I pick up the cut and I keep doing that. Okay. Then when I come back and make my 36-degree cut, I have only what I want. Okay. This illustrates what happens in practice. I set up my table saw sled at 54 degrees using this template. The first cut exits the board at the maple walnut border. Then I start getting a series of segments. And I want all these segments to be identical, so I need high precision while I make this cut. As I cut, if I make a mistake and I need to trim one of these pieces, then I trim all the others exactly the same. So if I make a mistake on this side and I trim here, I trim that same side on all of them. Same applies if I make a mistake here. When I end up with these, I need 10 to 12 pieces that are identical, cut at approximately 54 degrees. Then I take my template and set my table saw sled at 36 degrees, and I cut these. And again, I need all of these precisely cut the same. So if I make a mistake, I need to go back and trim all of them the same to correct that mistake. In that sense, this is a very forgiving process, because when I make the 54-degree cut, I can go back and recut. When I make the 36-degree cut, I can go back and recut, and that gives me good precision throughout. With the 36-degree segments, however, I also have to have high accuracy in addition to the precision, because that 36-degree cut determines how well these come together to form a tight blank returning. The 54-degree cut ensures that this is a straight line across here. Now, if this line is not straight, if it moves up a little bit and then back down, the human eye will look at it and see straight. So the 54-degree cut is precise but not necessarily accurate. Okay? The 36-degree cut must be accurate and precise. The precision is what makes all of these points come together. It makes all these lines go through the center point and come straight through. It's what makes these points come together at one place. Instead of having these offset, the high precision means that they all come together at the same place. I don't care about the accuracy. If it's up a little bit or down a little bit and it's the same all around, that's okay. My eye is still going to straighten that line out, provided it's reasonably close. Okay. Now here, high precision means all these points come together. Okay. This is an interesting phenomenon in that I've shifted this quite a lot, but it still looks reasonably good. If I shift this one even a little bit, it becomes highly apparent that it's wrong. So when I'm aligning these, if I have high precision and good accuracy on the last cut, everything comes together and I don't have to fool with it. If for some reason I do have to adjust, I line the center first, then I line these obtuse angles next, and I force any error that I can out to these points, because that's hard to see, whereas that is easy to see. But typically, if I'm careful, I don't have to do any of that. I come up with a star that looks like this. Okay. This is a relatively simple, forgiving technique that only requires one accurate cut at 36 degrees. Now, in order to design fancier stars, I need to take a look at how the lamination relates to the star. The center line of this center board is the outer edge of the blank. The outer edge of the lamination is the center of the star. So starting on the outer edge of the lamination, I move from the center of the star to the outer edge of the blank. Or I start at the outer edge of the blank and move to the center of the star. It's inverted, if you will. But that'll tell me how to modify these outer pieces of wood to give a different star, or how I can modify the center board to give a different border. Now, these offcuts I keep, flip them over and join them pairwise, and they form a 5-pointed star like this. And this will be done to the same accuracy and precision that your turning blank is formed. If I want, I can cut these at 36 degrees, the way I've marked here and here. That will close off that hole in the middle and give me something like this. So by making this accurate, I get something that looks like that. This one turns out I cut all these pieces in half and formed 2 of these for every star that I made. And it can be used as coaster or hanging Christmas tree ornament or something to talk about. Okay. I'm not going to discuss the star that you get from the offcuts. I'm going to concentrate on making this the turning blank, and you'll get this with the same precision and accuracy that you make them. This explains everything that I really need to talk about. Again, we start with a blank, or we start with a laminated blank that determines the type of star we make. I use a template that is basically a triangle that's 36, 54, 90, and I'll show you toward the end of the demonstration how to make that, and multiple ways to come up with one of these. Okay. And that describes everything that you need to know to make these stars. This is the table saw sled I've been using to cut these segments, and it's a pretty standard sled. It's made out of 3/4 inch MDO, which is a mistake. I made it out of MDO because I had the scrap line around. I should have used MDF like I do with all my other sleds, but it's good enough. It has a runner on the bottom. It runs in a slot on the table saw. And this one runs loose, which all of mine do, so they'll run freely. Now, in order to get the precision that I need, I can't allow this to wobble, because wobble is just another word for having an imprecise angle. So I'll bring my table saw fence up. That's going to push the sled up against the back side of that slot. And now it doesn't rock. It cannot wobble. And that means I'm going to have a base that's going to give me a precise motion, which means a precise angle. The next thing I do is I drill a hole through this swinging arm in the base for a carriage bolt. And that is a press fit hole. This bolt is in there tight. There's no play. And that aids with the precision. Okay. The next thing I need to do is position this arm at 54 and 30 degrees, and I need to be able to clamp it. So I've extended the base about 1.25 inches past the edge of the table saw, and that allows me to put a clamp on here. I can set this at 54 degrees and clamp it down, and then I'll tighten this nut so that the arm and this outrigger are both clamped down tight, so that there's no motion in this direction, so there's no uncertainty in the angle. And with all of these features, I now have a very precise cut. The next question is, how do I set this at 54 degrees? I'll raise my blade, grab the template, that triangle that I made. Let's loosen that up. Now I'm going to place one leg of this triangle against the blade, and I want to adjust this so that if I'm hitting a carbide tooth on this end of the triangle, I'm hitting a carbide tooth over here. I don't want to hit a tooth on one side and the body of the blade on the other. Okay, I'm hitting tooth to tooth. And now I'm going to swing this arm around. Until I have 54 degrees, and I'll check that by seeing if it rocks. If I have any doubts, I'll just double check. I think that has it. So now my table saw sled is going to move precisely through the blade. I have this angle set to 54 degrees, as accurately as this is 54 degrees. And it turns out for these stars, this is good enough. I don't have to correct this angle. I don't have to fool around with this. This angle I know is close enough to 54 degrees to make these stars look good. So this is all I have to do to make the 54 degree cut. I have the fence set at 54 degrees. I've got the laminated blank clamped in place. I have it clamped so that this joint line is lined up with this side of the blade, or this side of that curve. So I'm going to make that first cut, and then we'll flip it over and get ready to make the rest of the cuts. When I flip the blank over, I want this joint line on this side of the kerf now, because I want to leave that material. I'll clamp that down. Get my stop block in place. I'm going to cheat and give myself just a little bit. I'm probably going to end up with just a little touch of walnut on the end of there, and that'll be fine. Good. Okay, I need to cut at least 10 of these, so I'll probably cut 12. Let's see how this goes. Okay, I needed 10, but I cut 12 because bad things happen. And I wanted a couple of extras just in case something went wrong. But one thing I like to do is just line these up. I want to make sure this lines up all the way across. And they're smooth here and here, and of course on the bottom. It looks like all of these came out pretty good. So we're ready to go to the next step. Now I need to set the fence to 36 degrees. I'll take my triangle. I have a problem. This one's too big to fit inside here, and it's because of this bridge. Now, I like the bridge and this base extension over here because it allows me to keep this steady, and I get very precise cuts. But there is a problem in that it severely limits the size of piece that I can cut in here. So, to accommodate that, I tend to keep a small triangle around. You know, I haven't talked about this yet. I've been talking about precision and all of that, but part of the precision is keeping this surface clean and keeping all of these bearing surfaces clean. So this edge has to touch against the blade, and I have got to make sure it's clean. And the same is true for these two surfaces. So again, I'm touching a carbide tooth here and a carbide tooth here. I can hear it rocking, so I'm not quite there. Okay, I think that's it. Now I know I'm about to make precise 36-degree cuts, but I don't know how accurate that cut is. That accuracy is going to depend upon how accurate this template is. And this is the only time where I might have to adjust this angle a little bit after I make my cuts. Turns out, if I'm really careful when I make these triangles, I don't have to adjust them. I have to be careful making the triangle, and I have to be careful setting this angle so that there's no motion. And quite often I can make the cuts and I never have to adjust them. So let's see what happens. I'm ready to make the final cut on these segments to form the star. The first thing I do is line everything up and make sure everything looks good. You know, I have a constant line across here. Everything is smooth. The next thing I do is take a piece of sandpaper and just hit each one of these edges. I want to remove any burrs, any kind of fuzzy stuff that will mess up my ability to sit against that fence flatly. Okay. The next thing I do is mark on one piece how I want that to be cut. Okay. Now I'm going to remove these from the table, but I want to put them in an orientation so that every one of them is the same. So once I figure out how this one is oriented on the sled, I know how to pick up and manipulate each one of these. It sounds like a ridiculous thing to worry about, but I have flipped these over and cut them wrong. So everything is lined up in the same orientation. I'm going to discover how to orient this one on the sled, and then we'll be ready to cut. Okay, I previously had the fence set at 36 degrees and checked out, and it's really close. It's close enough I don't think I'm going to have to worry about it with these. The next thing I need to do is orient this piece against here. There's all kinds of orientations that I can look for, and I know all of these are wrong because this line is not parallel with the blade. Flip that over and slide it in there. And that's the one that I'm looking for. And what I'm going to remember is that the 72-degree angle is against the stop. The blunt edge is pointed out. And every time I pick up one of these segments, I'm going to say 72 stop, blunt out. And just like a mantra. And that way, if I get distracted, or if I just quit paying attention, I'm saying the same mantra over and over again so that I cut all these the same. 72 stop, blunt out. Okay. With that, I'm ready to start cutting. Okay. So I have the depth stop set so that this line is on the inside, or is on this side of the blade. Clamp down. Everything's good. Let's start cutting. Okay, let's see how we did. Clean these up a little bit. Flip every other one over. Okay, let's see how we did. I'm going to call that good enough. I can see a little bit of light coming through out here, and I think that's because I have a bad cut on one of them. And I can see just a little bit of light coming through down in this area. But by the time I squeeze that together and glue it, I think that that's going to disappear. When I get these right, they line themselves up, and it's really, really easy to make this work. But every now and then, I'll have a problem where things get shifted. And I've learned that if I start in the middle and align outward and push as many imperfections as I can out to the tip, that tends to give me the best star. So the first thing I do is look in the middle, and I make sure all these lines go straight through. That tells me I have everything lined up so that the middle is okay. The next thing I look for is this obtuse angle where the points, where the arms of the star join. That's critical, because if it's off a little bit, you can see that. And it's pretty glaring here, but it's not such a problem out here at the tip. You can see that, but it just doesn't have the visual effect that this error has. So I work my way from the center outward, and if I have to have an error, I try to force it to be on these tips. Okay. That turned out fairly well. I'm pleased with this one. So we did not have to go through and reset that fence. Okay. I'm ready to glue these segments together to form this star. So I have my glue, stack of paper towels, and I have a strap clamp that Christian Jensen taught me, and I really enjoyed this clamp. A piece of maple that I've drilled a hole through the center. Through that I run a parachute cord, and I've also drilled, before I cut this board off, I drilled a hole this way. That allows that cord to lay down in here and this wood to contact my blank, and that keeps it from unraveling when I tighten it. On the back end, I just tie a knot, insert a stick in there, and then spin that stick to tighten it up. And then I put a peg and a hole to keep the stick from unraveling. Simple, but I can clamp something small or something large, and I get good pressure holding these stars together. I prefer to glue these all up at once, and that way I can align everything the best I can, tighten the clamp a little bit, double check the alignment, and then go ahead and crank on it. or tighten it in steps depending on how things move. That's my first choice, but sometimes that just doesn't work. Sometimes there might be a gap that's unacceptably large and you just haven't been able to get rid of it. And in that case, I don't use the strap clamp. Or there may be a misalignment that uniform pressure will not correct. It is with this rubber band I have uniform pressure, and on this particular star, that's all I need to pull all these joints into alignment. But it sometimes turns out that that's not true. So in that case, I can't use the strap clamp. I need to use something else. And for those situations, I used a half ring method with a rub joint. So I'll rub these two, create a rub joint with these two segments, and I align this obtuse angle. So I get the best alignment I can there. I do the same pairwise. Then I use a rub joint with these, joining these two, and I don't align the point out here, I align the point here. And that's so that when I add this last one and I align the point here, I get the best line, the straightest line that I can get here. Because the next thing to do is to sand this flat. I do the same thing over here. And when I pull these together, it would take care of that gap. And if I had a misalignment to begin with, because I have a good clean line along here, I can slide this up and align this obtuse angle, force the error out to this point where it's less obvious, clamp it, and now I have a good looking star. This arm may be a little shorter than the others, but if I have a pretty straight line here and here, when I sand them, they'll form a nice looking star, and that shorter arm won't be apparent. Okay. This star is held together well with just a rubber band. I'm pretty sure the strap clamp is going to work. So let's go ahead and glue this together. Spread this out. Now, I'm going to be a little bit generous with the glue because I don't want this setting up before I get around to aligning everything. See how I mishandled that one? I want to make absolutely sure I put it on with the right orientation. Because it's amazingly easy to glue these on upside down. I tend to work quickly so that I have time to move these segments around at the end so that I get the best alignment without the glue setting up on me. Sometimes my shop will approach 100 degrees. And in those conditions, I found it's best to wait till the morning. This one I need to glue both sides. First thing I do is I stop and I look, and is this a star? It's really easy to put, especially that last piece in place, but it's easy to make a mistake when I get excited. I've got the glue flowing. get that wrong. So get my clamp in, and I'm going to set this up so that the center of the clamp is centered on these two. So I push both of them uniformly. Take the parachute cord and pull it up to the midpoint of these segments. Get the knot tied. And now I'll give it just a couple of twists to just pull everything up tight. Peg it. And now clean the glue off. You see how everything can slip and slide? That's what I want. Once I get the clamp on, I tighten it just a little, just enough to cause squeeze out everywhere. And then I stop. I clean everything up, and I start checking the alignment all around this star to make sure everything's as good as I can get it. And I want to be able to move everything. Once I'm happy, I'll crank on it just a little more, clean it up, and check everything. And that, by check everything, I mean both sides, to make sure both sides look good. And I just keep checking, cleaning, and tightening until I have this clamp tight enough. Every now and then, and I've never quite figured out why, something will shift, and I'll start seeing misalignment. And it typically happens when I start with mild pressure, align everything, and then I just really crank tight on it. Something happens and I can get some misalignment in there. I found it's best to just go in steps. Okay, and again, check both sides as you go. So this has been sitting long enough, about an hour. Take this clamp off. And here's our turning blank. I'm going to run this through a thickness sander and then bring it back so you can see a little bit better what this looks like when it's sanded. Here's the star, and it's been sanded to 150 grit. And it lets me see a little better how well I'm aligned, and I'm happy with the alignment and the obtuse angles. I have a couple of places on these tips where I'm just slightly out of alignment, but I have to look closely to see it. So overall, I'm quite happy. If I look closely enough, I'll see a black line right along here. And that occurs on each one of these. And I suspect what's happened is that when I made that 36-degree cut, I sand this edge to take care of the burrs. And I may have just sanded it deep enough that I left a V-shaped trough right in here. And I haven't sanded it deep enough to get rid of that. So I suspect that dark line will go away. I do have some chip out in the center. And on the other side, it's even worse. But again, if I either turn this as the bottom of a bowl, or if I just sand it deeper, I'll get rid of that. So it's not anything that I'm going to worry about. Overall, I'm quite happy with the way it turned out. Everything is aligned well. I have good distinction between the star and the border. I have good alignment everywhere that I want it. The chip out's not enough to concern me. And I have a good tight fit on all of these joints. So I'm very happy that this is going to turn into something quite nice. That's about all I have to say about the star. But in the process of making that star, you recall we had this scrap. I can close this hole off by calling this my reference line and making a 36-degree cut here and another one here. All of that will close off. And here I'll get a star that's complementary to this star, where the border becomes the star and the star becomes the outline. I haven't explored what I can do with these very much, but that'll be something that I can deal with in the future. One thing I have made is the obvious, a starfish. that pretty much concludes everything I need to say about this process. I hope that you've seen every step along the way in enough detail that you can reproduce this work and do it yourself if you choose to. And with that, I really want to thank you, and I appreciate you watching this video.